My name is Jordan Eldredge, and while I work at Meta, this presentation is about a side project that I maintain. But it is definitely inspired by what I've learned from the tech that I see at Meta. So the talk is about a project called Grats, which is a TypeScript library for building GraphQL servers with TypeScript, and a particular kind of style of building GraphQL servers. And it's both a useful tool that people are using in production at companies, but it's also a sort of proof of concept to bring this approach to TypeScript. So the talk is both about Grats itself and this approach generally. And I've tried to carve off this name implementation first to describe this style of GraphQL server. There's already some language in the ecosystem for describing different ways of building GraphQL servers. One is schema first, where you write some SDL, and then you implement it with some code. And you might have some code gen that assures that, or type gen that ensures these two things match up. Another way that's well described in blog posts, etc., is code first, which in JavaScript often looks like this, where you write some resolver code using some language. This is Pothos. It helps make the contract type safe. And then with that, you're able to either generate SDL or have a running server that can do introspection. So implementation first falls under the umbrella of that second category, code first, but it's a special flavor, where instead of using something like this, which is, to my eyes, basically a DSL on a DSL. This is a builder pattern with a special TypeScript API for defining SDL. When I write this, I have to think about TypeScript, I have to think about SDL, and I have to think about my product code and the Pothos API. And this is Grats, and this is implementation first. I write my TypeScript, and I annotate it to say which properties, which types I want to expose on my server. So with implementation first, you get your names and types are derived from your implementation. It's type safe by definition. There's no magic TypeScript thing going on or other typing language to ensure that these two things match up, because there's only one thing, a single source of truth, and fewer APIs to learn. There's annotations, but no actual APIs. This link is a blog post I wrote trying to articulate this distinction. Now, why hasn't there been a sort of robust implementation first TypeScript way of doing this before Grats? And the challenge is that most such libraries depend upon type introspection. So there's a great library, Strawberry. I highly suggest you check it out, which is able to use Python's rich, dynamic programming APIs to inspect, what are the method names, what are their types. But as you can see, as my code deteriorates here, in TypeScript, the types are stripped at build time. The names might be mangled by a minifier. We don't have any of these things. So Grats' approach is to use static analysis. Grats parses your source code and looks at the text of your code. It doesn't evaluate it. It doesn't type check it. It just looks at the text of your code, and from that is able to derive GraphQL. Now, of course, TypeScript is not the same as GraphQL, and so we have to decide what TypeScript is valid GraphQL, or can be mapped to valid GraphQL. And sometimes you'll try to put an annotation on something that isn't valid GraphQL, and in that case, we need to error. And so really, Grats is just this pure function that takes in your source code and produces either a helpful error or GraphQL. And it goes to great lengths to follow TypeScript's sort of philosophy, which is TypeScript is not a subset of JavaScript that's type safe. It's types for JavaScript as it exists in the world, as people actually write it. And so Grats' goal is to take JavaScript, TypeScript idioms and let you generate GraphQL from them. Let's do some live coding. But wait, I want to clarify. This is going Part of this demo is to show how easy it is and how quick you can do it. But I don't want you to conflate that with like, oh, this is great for prototyping. This is how Meta writes GraphQL. This does scale. And whether or not you're using Grats, and whether or not Grats is a robust project or is used in industry, this approach does scale. So I want you to take that away, even if I'm showing things that look lightweight. All right. So I've started myself off with this, like the minimal way to create a yoga server. And I'm going to implement sort of like a blog-shaped thing. So I've given myself a class for user and a type for post. And this is the file where I'm defining my types in their sort of product domain. And every good code base should have something like this. Every well-factored code base should have a place where I've defined what my types are, in their domain context. Now I want to make some GraphQL. So I'm going to say npx grats in watch mode. And this will run that pure function in a loop and give me errors down here or produce TypeScript or GraphQL. So this should be a type in my system. So I'm going to annotate it as such. And I've got my first error. This is error-driven development. And I actually love this about Grats. One of its goals is that you shouldn't need to consult the documentation so much. The compiler should drive you towards the outcome you want. And it's saying, you don't have any fields. That's not valid in GraphQL. Here's how you would add a field. So let's add this field. And now we're green. And we can see that it has generated a schema for us. What's more, it has generated the GraphQL JS code to execute that schema. Now, let's say that we want to actually be able to access this type, so we need some kind of query field. One idiomatic way to do that in TypeScript might be a static method. Let's call it user by name. Actually, let's call it user by name. And it's going to take a name, which is a string, and return a user. Now, an idiomatic way to do a name that is a property that you pass in the constructor in TypeScript is like this. Public, I should say. And let's see, we've gotten an error, parse error. Can't have a semicolon here. And we can see that Grats here, let's put this guy over to the right here, we can see it as we go, still sees this TypeScript idiom as a field. And so now we can pass our name. And if we want this to be a query field, we can say this is a query field. And now we have an error. It says expected GraphQL field static methods class to be exported, because Grats going to need to import this class. OK, that's fair enough. This is still reasonable TypeScript. And now we have our user by name. But this is already on user. We probably wouldn't want to call it user by name. This would just be like by name, maybe. But that doesn't look good in our schema. So Grats allows you to alias it here. So if you have some GraphQL specific thing, you can just add it there. Now, we have users. We can get our user by name. But often in GraphQL, you would want to get maybe like the current user. So how might we do that? Well, it's going to look similar. This is going to be like me, but it's not going to take any arguments, and it still has to return a user. Well, how am I going to get the current user? I would need access to like the HTTP request, something that has context of how this is being requested, some kind of context. We have that in GraphQL. And you can see in my yoga setup, I've come up with this context type. And so in Grats, I can say, well, this is my GraphQL context type. And now anywhere that I want that, I can say, I would like access to the context, and I want context.username. And there's no arguments. This is two different fields with the same name. Don't do that. You got an error. We now have a me attribute property here. And we can actually see, if we look at the generated schema, that Grats has figured out that I want this static method called with the context argument, which is this third argument here, and passed in. Well, we've gotten pretty far with our user, but this is not looking very much like a blog, so we better add our post, or have some posts. And again, we can annotate it as a type, and mark this as a field, and we should see it appear in our schema. Now, one thing is, we might want to add some additional details, like what is a post in our system? Well, what's the idiomatic way to add a description to a structure? Oh, and also you can see here that this is a type, this is not a class. So that's just another TypeScript idiom that Grats is able to support that does have a sort of unambiguous mapping to GraphQL. So we can say like, this is a post in our system. And this gets propagated to our GraphQL comment. Now, if we want to have a blog, we better have some posts, like a list of posts. So we'll have posts, and it's going to return an array of posts to start with. And we'll return all of our posts, and we'll make that a field. So we've got our plural field here. But we probably don't want to get all the posts. Now, I'm not going to give all of Sabrina's talk about connection from last year, but we do want to say we need some kind of structure for holding this collection of data. So we'll make something lightweight here. And we also want some way to paginate. So we need some arguments here. So let's get the first number at offset. And you see we've got an error here. This is another place where TypeScript and GraphQL don't really line up. It's saying here that GraphQL supports ints and floats. Number is ambiguous. I don't know what to do with that. And then it suggests, well, you can use this special type exported from Grats. This type is simply an alias of number, because TypeScript does not have a more specific type. And if I use this here, that's enough to tell Grats that I want ints here. So let's implement this. First. Now, we might also want default values here, right? Maybe the sensible default is to get the first page of 20 posts. Again, in another solution, we need like, okay, what is the Pothos API for annotating an argument to say that this argument has a default value? Well, in TypeScript, there's an idiom for it. And if I use it, Grats can pick up that idiom is that's what I want in my GraphQL schema. And maybe I want my Now, there was a type error there in TypeScript, and I think that's just a good reminder that like all of this is type safe by TypeScript, and because Grats accurately models the GraphQL relationship between that TypeScript type and GraphQL type, this is all type safe end to end. So now let's come up with some kind of like collection for our post. Maybe we want to show these posts, this page of posts, but also how many there are in the total list. So we'll add a new type for that. Say post collection, because this is not going to be connection spec, but something like it. So we have our items, which are the array of posts, and we have count, which is an int. And each of these are fields. And so now we can actually say we're going to return this. And this is going to be items and our count is going to be posts.length. Type error, I've likely misspelled something. Now, if I want to have lots of different things that live in collections, this is the TypeScript, this is the GraphQL way to do it. I have to define a new type each time. But that's not the TypeScript way to do it. What we would like to do in TypeScript is use something like generic types. But of course, that doesn't exist in GraphQL. But Grats can figure out that mapping for you. And it can say, OK, you've used a generic, but you've used a generic of a GraphQL type. And I can figure out that this is still a post collection. It's currently deriving its name from a concatenation of the parent type in the generic. And that this is a collection of items. We could see here that if we tried to make this a collection of user, that this would be a user collection returning users. And that we would get a type error, because this is not a collection of users, it's a collection of posts. So this is just like a starter walkthrough of like all the different idioms of my host language that have intuitive, unambiguous mappings to GraphQL that we're able to support. The last thing I want to show is if you saw Benji's talk yesterday about nullability, you can see that Grats has made all of our fields nullable. This is the GraphQL best practice. Not everyone's on board with it. Not the right trade-off for everyone. But Grats starts you there as its default. But as we learned in Benji's talk, if we know the semantic nullability of something, we could annotate our schema with this semantic non-null directive. And Grats is in an excellent position to know what the semantic nullability of all my types are, all my fields, because it can see the TypeScript types. So there is a config option we can enable for Grats. And it's going to rebuild our schema, defining the semantic non-null directive, and attaching this directive in all the places that are non-null. And we could see, for example, that if we make count nullable, that becomes nullable, truly nullable in our schema, semantically nullable. So I think this goes to show the power of your code really is the source of truth. Your schema is a document that describes the capabilities of your server. And the source of truth for the capabilities of your server is the code that implements your server. And more generally, a well-designed application should have a place in it where it defines its data in a business domain context for uses that are not GraphQL. This is in TypeScript. I might want to use GraphQL for my native app. I might want to use React Server components for my web app. If I had done all of this as a GraphQL abstraction, been like, I'm going to model all my business domain stuff in GraphQL, and then I wanted to use React Server components, well, I'd have to start over again. But if I have it in this layer, this is a generally reusable layer that just happens to be exposed as GraphQL. And I posit that this abstraction is the right abstraction to be exposing in GraphQL, generally, with relatively few exceptions. So Grats is an attempt to bring implementation first, style, server development to TypeScript. The advantages are that GraphQL becomes this really thin layer that gets out of your way. It's not a thing you spend a bunch of time thinking about. You think about modeling your data in its business context in your language that your server is written in, and then you simply annotate the things that you think belong in the schema. And you get help along the way if that can't quite fit into what GraphQL is able to express. Grats is a purely dev time dependency. It generates GraphQL.js code. It does not execute anything at runtime. It does export types as well, but those are, again, dev time. And there's simply less mental overhead, right? We looked at that example earlier where we were having a builder API we had to know. We were thinking about SDL as we used our builder API. There's none of that in this approach. And I think the other takeaway that I would like to share is just an observation that even in languages which you might think are not strong enough to do implementation first, that the static analysis approach should be a lowest common denominator, right? Any language that has types that can be parsed could have an implementation that looks very much like this. Grats has a playground. So if you're interested in trying any of this, you can check out the playground. And just to sort of show you that it works, let's take our example from today. We can't import our context from that file because we're in a playground, but we can copy paste it. And we can see that we get all of that same schema. We get all of that same TypeScript code generated here in our browser because Grats is implemented in TypeScript, so we can do that. So I hope that this is a call to action to rethink maybe how you might approach your next GraphQL server, and that Grats provides a very quick, tangible way if you want to get your hands on trying it out, seeing what it feels like, whether that's in our playground or in your IDE. Thank you. I can take questions.
Is there any kind of data loader support?
So there's not built-in data loader support. Again, the goal is to be entirely build time. But a common pattern would be to attach that to your context. One thing we do support is what are called derived contexts. So if I have an additional type that I might want to access ad hoc in some resolver that is sort of derived from, maybe it's like a database handle, maybe it's a data loader for a specific type, I can write a function, data loader. In this case, let's have it return a request, I guess, or let's have a type. And if this takes a context as its argument, Grats is able to determine that there is a sort of derived context which it can derive from the context. I need to export this as well. And if I ask for this DL thing in one of my resolvers, you can see that the schema is able to, let's see, where's my me field? To give me the data loader directly without me thinking about the implications of, and I guess the main advantage of this pattern is that it allows you to have methods that are generally reusable, right? If there's something that happens to be in your GraphQL context, you don't have to couple your individual method to a GraphQL context being a required parameter. Just anyone who can give me this data loader is able to load this method. Question is there support for federation? This is actually something I'm interested in looking at. So for example, the lookup directive, if we have this constructor, could we maybe annotate this as GQL lookup or something? We actually do have first-class support for annotating with directives. But I think ones that are specified, Grats could sort of do the additional validation to say, does this map? So it's not something that I'm explicitly aiming for. And I think part of that is because, I won't go into that. But I think it's not a thing that we explicitly have features for. But I think the overall model of Grats is that it should be able to, there's that slide of it returning GraphQL or error. It doesn't need to be done, right? We can continue to add more understanding of hey, this is a new thing that used to be an error, but now has an intuitive GraphQL equivalent. And I think there are many things that would be interesting in the composite schema spec for us to be able to support. However, I'm not building things that don't have concrete use cases. So if anyone's interested in that, like reach out on GitHub, and we can battle test it with an actual use case. Type support for scalars, yes. So we do have, you can say I have a scalar, and I have foo, which is actually a string. Oh, it doesn't like this. And so we should have a scalar foo. You can do at specified by and give it a URL. I don't know if it's going to pick that up correctly if I've spelled it correctly. Oh, it says specified by tag has been deprecated in favor. Oh, it gave me a helpful message because I forgot I deprecated that. Thank you. Oh, I can actually copy this. I need error-driven development because I just am not very smart. Specified, oh, by. And so we should have our specified by here on our scalar. It does not yet have built-in support for defining serialize and deserialize, but there is documentation on how you can still do it. So you can't get, so I'm working on a TypeScript plugin, which is able to do some of these things. Autocomplete in the doc block is difficult. This is not fully released yet, which is why I didn't mention it in the talk. But it is able to do things like, I'm not sure if it yeah. So you can see here, I've got my Grats error showing up in my editor, not just in my IDE. And this is powered by the actual TypeScript runtime. And so this is actually like TypeScript's in editor thing pulling this in for us. There's still some bugs where it puts the error too many times. And it's only a subset of errors, the ones that can come fast. So you still would want to run the full mode, but we may get to a full build fast in the TypeScript plugin. So we have a page of recommendations in the docs. And let's see. I'm not sure where it is. But one of our recommendations is basically, it's here. Yeah, check your schema. Is that you check this schema document into your repository. So while it can be derived, it should be checked in with each commit, because one thing that I think the schema first people have right is that the schema is a very important contract. And while you should write your code in the language that it's written in, you must at some point contemplate, okay, let's check in. What are the schema changes I'm making? This is a contract I'm making with the outside world. But I believe that code review time is a perfectly reasonable place to have that conversation, and that developers are smart enough to be thoughtful about the TypeScript code they're writing and the implications that can have when they add that annotation, and be double-checked in code review. Oh, I see, to highlight breaking changes in the editor. It's an interesting question. I guess it would require us to know the currently committed version of the schema, but it's a good suggestion. I guess one other thing along the lines of breaking changes is that TypeScript has an idiom for deprecated. Don't use this. Which similarly, where did I put it? Posts. Grats will pick up and translate into the equivalent TypeScript annotation. I'm a little over, but I maybe could take one more. Cool. Feel free to come find me. Would love to chat more about it.